Today's goal is I can solve problems using the relationship between the angles formed by intersecting lines. The other day we had this exact same goal when we were talking about complementary, supplementary, and adjacent angles. Today we're continuing to talk about special angles that are formed when we have intersecting lines. You should have these three words already defined in your notes: congruent angles, vertical angles, and corresponding angles. If you don't, make sure that you take care of that first, defining those words. All right. Can we find the missing angles given just what we have in front of us? Absolutely we can, if we use our knowledge of special angles that are formed when we have intersecting lines, which in front of us we have intersecting lines. So I know the point of intersection is a point. So could I figure out angle Y given the information in front of us? Yeah. Angle Y is a vertical angle to angle 65 degrees here because they share a vertex and they are directly opposite the vertex. Therefore, they are congruent if we look at our definition of vertical angles. So the measure of angle Y would be 65 degrees. Now, can I find the measure of angle X with the information that I have in front of me? You bet I can. Angle 65 degree and angle X, they lie on a straight angle. So that means that they are supplementary. The sum of their measures should be 180 degrees. So if I go 180 degrees and take away 65 degrees, that will give me the measure of angle X, which would be 115 degrees. Can we figure out the measure of angle Z given this information? You bet we can. Angle X and angle Z, they share a vertex, and they are directly opposite the vertex. Therefore, by definition, they are vertical angles. Now, I know that might be slightly confusing because really they're horizontal on the picture in front of you, but by definition, they are vertical angles. They are congruent, and that means that they have the same measure. All right, the image that you see in front of you are two intersecting lines. That means something special is happening with the angles. So let's go ahead and let's respond to question 1 here. What angle is vertical to angle 3? Well, there's my point of intersection, so there's my vertex. Vertical angles share a vertex, and they are directly opposite of each other. So that means that angle 2 is a vertical angle to angle 3. Looking at question 2, what angle is vertical to angle 1? Again, vertical angles share a vertex, and they are directly opposite that vertex. So that means angle 4 is a vertical angle to angle 1. They are congruent. They have the exact same measure. One way I can show that, 6th graders, is going like this and putting a slash through my arcs, showing that those two angles are congruent. And for angle 3 and angle 2, I could do this. Put 2 slashes through so that they're separated from angle 1 and angle 4, showing that they are also congruent because they are vertical angles. Going to question 3, what angle is supplementary to angle 2? Well, I'm going to take some of that stuff off there. We have angle 2 here, right? Supplementary, well, there's my straight angle with a ray coming off. So that means angle 4 would be supplementary to angle 2. And also, here's a straight angle with a ray coming off. That means angle 1 would be supplementary to angle 2. The total of their angle measures should be 180 degrees. And the total of their angle measures should be 180 degrees. Question 4. What angle is supplementary to angle 4? Well, here's a straight line with a ray coming off. That means these two angles are supplementary. They would add up to 180 degrees. And here's a straight line with a ray coming off. That means these two angles are supplementary. They have to add up to 180 degrees. So it would be angle 3 and angle 2. This image is a little bit more intricate, meaning there's more going on. What do you notice right when you look at this image? I see a line here, and I see that right angle, that square corner. It means 90 degrees. So that means that this big angle is 90 degrees, this big angle is 90 degrees, and that big angle is 90 degrees. So that means we got lots of special things going on. If we got 90 degrees, there could be complementary angles. I see straight lines, there could be supplementary. We have points of intersection, so there could be vertical angles, adjacent angles. Let's go ahead and let's answer some questions here. All right, question 1. We have angle 1 is a complement to what angle? Well, we already talked about how we have perpendicular lines, so that means that these two angles have to add up to 90 degrees. So a complement to angle 1 would be angle 2. Question 2. If angle 1 is 42 degrees, what is the measure of angle 2? Well, if angle 1 is 42 degrees, we know that it is a complement to angle 2, so we would just have to do a little math here. Complementary angles, their sum is 90 degrees. So if we go 90 degrees and we subtract the known angles degrees, we get 48 degrees. So that means the measure of angle 2 is 48 degrees. Going to question 3, if the measure of angle 2 is 48 degrees, what is the measure of angle 6? Well, there's my point of intersection. Angle 6 shares a vertex with angle 2. They are directly opposite the vertex. They are vertical angles, which means they are congruent, which means angle 6 is also 48 degrees. And I actually want to stop for a moment and go back to question 1 here. It says angle 1 is a complement to what angle? Angle 1 is also a complement to angle 6. They are not adjacent complementary angles, right? They're not sharing a side. However, when you go 48 degrees and you add 42 degrees, that gives you a total of 90 degrees. All right, if the measure, this is our last example for the day, of angle 2 is 53 degrees, find the measure of the remaining angles. So angle 2 here is 53 degrees. We can definitely find the measure of the remaining angles. There's my point of intersection, so there's my vertex. I could go, angle 2 and angle 3 are vertical angles. They share this vertex and they're directly opposite, so that means they're congruent. They have the same measure. That means angle 3 is also 53 degrees. And angle 1 and angle 3, I see a straight angle with a ray coming off. They are supplementary, so that means they have to add up to 180 degrees. So if I go 180 degrees and I subtract 53 degrees, I get 127 degrees. And then angle 1 and angle 4 are vertical angles. They share this vertex and they are directly opposite each other. So that means that they are congruent. Since they're vertical angles, it's 127 degrees. If I were to take a snapshot of this information right here, and then take that picture and slide it down this line, what would I get? Well, this is what I would get. And what you see in front of you now are one line here, one line here. We know those two lines will never intersect. And then I have a line that cuts them. So, what angles go with parallel lines cut by another? Corresponding. And what you'll see is this angle 2 right here is the exact same thing as this angle 2 right here. They are congruent. They are corresponding angles. They are in the same location. If this figure was separate from this figure, they would both be in the upper right. So that means that angle 2 down here is 53 degrees. And angle 4 and angle 4 here are corresponding angles. They're congruent. So that means their measures are the same. This is 127 degrees. And still going with my corresponding angles, angle 1 here and angle 1 here are corresponding. So that means that they're congruent. This is 127 degrees. And then angle 3 and angle 3 here are corresponding angles. That means they're congruent. They'd be 50, or this would be 53 degrees. This is the assignment that goes along with the lesson, so I'd just like to walk through a couple problems with you so that you get an idea of what's going on. And again, all of this pertains to what we've talked about over the last couple of days, and that is that when we have intersecting lines, something special happens with the angles that are formed. So go ahead and read the directions. Something that's important that's stated in the directions that I want to point out is this part right here. Assume that lines in each figure that do not intersect are parallel. We need to know that information, or we need to be shown it, because only when we have parallel lines cut by another are our corresponding angles congruent. Let's go ahead and let's get started. We're going to look at angle 1 here, and I'm just going to cover this up, and I like to do this so that I'm not looking at so much. How could we figure out the measure of angle 1 given what you see in front of you? Well, we know that the 140-degree angle and angle 1 are supplementary, right? There's a straight angle here with a ray coming off. That means these two angles that are adjacent have to add up to 180 degrees. So we can go 180 degrees minus 140 degrees. And those are nice numbers to work with. That gives us, or that's a difference of 40 degrees. That means angle 1 measures 40 degrees. Now, let's see. We also have to figure out angle 2 and angle 3. So if we look, and if I were to take a picture of this intersection point right here, and then take that image and slide it down right over the top of this intersection point, angle 1 and angle 2 would lie perfectly on top of each other. That means that they would be corresponding angles. They're in the exact same location. Corresponding angles, when we have parallel lines cut by another, are congruent. So that means angle 2 measures 40 degrees. And now we can think about finding angle 3 a couple different ways. We know that these two angles right here, angle 2 and angle 3, have to be supplementary. And also we know that this 140-degree angle and angle 3 are in the same location. So they would be corresponding angles, therefore they would be congruent. So I can also say that angle 3 would be 140 degrees. Let's look at one more together here. Find angle 13. All right, angle 13 here. How could I figure out the measure of angle 13 given what you see in front of you? Well, here's a point of intersection, so there's a vertex. This angle is directly across from this angle, and they share this vertex. That means they're vertical angles, and vertical angles are congruent. They have the same measure, so angle 13 would be 45 degrees. Why don't you go ahead and do the rest of this assignment to the best of your ability on your own. Remember, you need to recall complementary, supplementary, adjacent, vertical angles, and corresponding angles to help you be successful on this assignment. So having your note sheet out next to you with those definitions would be beneficial.